All right, so in this question, we are given the age of a personnel, all right, and the time spent in service. So the age is, for example, 25, and the time spent in service in month is 66.2 month, all right? And we want to figure out whether there is a correlation between the age and the time. So the age will be your independent variable, which is the x, and the time would be the dependent variable, and it's going to be the y, right? So let's see. The first question is asking you to plot the scatter plot, all right, to draw the scatter plot. And for this, it's really easy. You just have to click on here, and then you are supposed to enter the numbers. So the x is going to be first, which is, for example, 25, and 25 is connected to 66.2, and you just go ahead and plot it. All right, so if I close this, you get the point already plotted there, and so on for the remaining points, right? So for the second one, you're going to be, for instance, is 25.5 for the x, and the y would be 71.2, and again plot it and so forth. So I'm going to stop the video and keep going with this, right? All right, I'm done inserting the points, and as you can see, this is a scatter plot, has 5 points in here, and it seems like there is a line going through this. Well, it's not perfect line, but anyway, so it could be a linear regression. All right, so now let's submit the answer, check this is whether correct, is good. The second question is asking you about the R, all right? So the R is the coefficient of correlation. Now, in order to do this, again, I'm going to have to enter this data again into TI-84. So, by the way, this is not the only way to do it. You can do it even with Excel, but we're going to be using the TI for now, right? So, we're going to start with going to statistics and edit number 1. Go, and you are supposed to enter the x's here in L1 and the y's in L2. So for the x's, it's going to be 25, enter, 25.5, enter, 26.5. I'm going to stop the video again, right? Okay, I'm done inserting all the numbers in the table, so you can double check whether the number is correct or not. All right, so now what I'm supposed to do, I'm supposed to look for the regression. All right, the way to do it is, again, go to statistics, you go to calculate this time, and you can see here linear regression for number 4, ax plus b. All right, so supposedly you're gonna go there and you're gonna insert L1 in the table. For x's, L2 you're gonna be inserted for the y's. The frequency, you can skip it. And here you can have it as a good habit, right? So sometimes they ask you to insert, to calculate for certain numbers. It doesn't hurt, right? So to store it in the memory of the calculator. So you can go to vars, and then you go to y vars, and you select functions, enter, and you select the function that you want to call it. Y1 is fine. So, and then you're gonna start the calculation. Okay, as you can see here, I get the A, I get the B. However, I did not get the R, what I want, right? The coefficient of regression. And that is due because the calculator by default is not on. This diagnostic for the R is not on. So I have to go every time and turn it on. All right, just in case is not on the calculator, right? So how can you do this? So you're gonna go to the catalog over here in 0, so second, and then catalog, and the function that you're looking for is called diagnostic on. So you can speed forward with the D. So you can see the D here. If I click here, you're gonna go to the D letters, and then I'm gonna go to diagnostic. All right, scroll down out and all the way to diagnostic. You can see diagnostic off and diagnostic on. What I want diagnostic on. Enter and enter again. So right now the diagnostic on. So if I go to statistic again one more time, do the calculation, go to number 4 and enter, and usually the data is there already, so I can keep L1, L2. I can store it again if I have to. All right, so it's already in the memory, but let me store it again. So I'm going to go to vars and then yvars and then functions and then enter, and then keep it in y1, enter again, and then you go to calculate and then this. As you see here, the menu had changed completely whenever the diagnostic is on. It's giving you the R squared, which is the coefficient of determination, which is 0.66. Is not really good. Well, it's okay, but it's not really close to 1, right? The closer to 1 is the better. And it's giving you the R, and that's the R that we are looking for. So the R is the coefficient of correlation. So if the R is positive, it means that the line having a slope, positive slope. And as you see here, A is 9.049, right? So it's positive slope. And if it is negative, so you're going to be the A negative. You're going to be a negative slope, and the line is going to go downward. All right. So that's what we needed. We needed 0.816. Whenever you round it, it became 7. All right. And let's check the answer. Okay, great. Now, for the hypothesis testing, so we have always for the coefficient of correlation, hypothesis testing is always rho, all right, equals to 0. And for the second one, it's going to be rho different than 0. So it's always this way, right? So never change here. Check it. And right now it's asking you about the critical values, right? So at the level of alpha equals 0.05, remember we have the n equals to 5 units, 5 entries, all right? So 5 points basically, right? So what you want to do is you want to use the table, and this table, as you can see here, the degree of freedom is n minus 2. So 5 minus 2 is going to be 3. So you're going to be looking into this column over here. All right, 0.05, and the number that you're looking for is 0.878. So let's go and put it in 0.878. So that's going to be our critical value. And it's going to ask you whether you're going to accept or reject, right? So let me take you to the whiteboard and try to explain this. Okay, so I already wrote this chart. So basically what we have, the rho equals to 0 is over here in the middle, and we have the R criticals, right? So the R criticals, we find one plus or minus 0.878. So this is a negative 878, and this is a positive 0.878. So now what the meaning of the R criticals? So here you're gonna be basically a wall, all right, is separating your decision. So if I am from the side, basically here, this is alpha over 2, all right. If I am the side of alpha over 2, this is going to be reject 80, all right. Similarly, from this side here, I'm going to be rejecting 80. Okay. So what happened in between? In between that the acceptance zone. So if I am in between here, so you're going to be accepting, or do not reject better, right? Okay, do not reject here, 80. Okay, so now how I'm going to make my decision is based on the R that I calculated here. So do you remember the R is 0.817? So I'm going to plot it in my chart. So R is going to be 0.817. So where are you going to be falling this R over here? All right. Obviously, 0.817 is somewhere in here. So you're going to be, this is your R. You're going to be somewhere here. So your conclusion will be do not reject 80. So what the impact of this? All right. So it happened that if you are within this zone, do not reject 80, there is no regression. No regression. So you cannot talk about regression anymore, and you cannot make a simulation basically, right? If I'm gonna fall into the rejection zone, this one or this one here, it's gonna be a regression. So there is a regression here, and so forth. And the same thing here. And what you want all the time in order to start calculating your R, you wanna always fall into this zone over here. You wanna have a regression and you wanna make a simulation, right? However, in this case, sadly we don't have the R is not falling into the regression zone, so I have to reject no regression. Therefore, I cannot make any calculation, right? So we go back here. We're gonna reject the null hypothesis. We are not rejecting the null hypothesis. Do not reject the null hypothesis. You can check it. All right, and if you're gonna ask you there is or there is not enough evidence, and of course there is enough evidence to conclude that a significant linear relationship exists. No, there is not. Okay, I guess. All right, there is not enough evidence to conclude there is a linear regression, all right, or significant relationship between the two variables, all right? And you check it, and here you go. So this scenario is not always the same. So obviously, if I had the other way, if I had the R, all right, into the rejection zone, I will be rejecting, and I will be there is enough evidence, right? Okay, that's all for this question. I hope this helped.